So I'm not officially sharing this session, but for the sake of leaving in time for dinner, I think we should start. So the first presentation of this session is by Amina Rezoug. Is that how you say it? And it's titled Connecting Spaces and People, Point Cloud Segmentation in the Context of Design Anthropology. Please, Amina, yeah, you can start.
Okay. So hi, everyone. My name is Amina Rezoug. I'm from Istanbul Bilgi University. And today I will not present a tool, neither a project. So I will present a theoretical framework and a comparative literature review, let's say. So the main aim of this presentation is connecting spaces through the medium of, or represented through point cloud segmentation, and people through the context of design anthropology. So of course, I know that you are all aware of what 3D point cloud is, but to give a very brief definition, 3D point clouds are increasingly utilized in architecture application due to their ability to represent complex geometries and spatial relationships. So the segmentation of these points is crucial for extracting meaningful information from the data. So 3D point cloud segmentation can be roughly categorized in two different titles. So one would be the point cloud segmentation, which is like edge-based or region growing, model fitting, or unsupervised clustering, while there is the point cloud semantic segmentation, which is more based on supervised machine learning, deep learning, and hybrid methods of segmentation. And 3D point cloud semantic segmentation can also be divided in two different categories. So the first one is direct segmentation, and the second would be indirect segmentation. So in direct segmentation methods, we extract features directly from the point cloud data, while in indirect methods, it involves transforming the point cloud into regular 3D voxel meshes or multi-view representations. So PCSS is essential for assigning semantic labels to points in 3D space, enabling the extraction of meaningful information from the point cloud data. So it's using mainly deep learning architecture that has become an important segmentation technique. So architectures such as PointNet and its variants have remarkably performance in segmenting 3D point clouds, and these models reveal the unique properties of point cloud segmentations, such as unordered nature, varying density, and to learn the robust features of the representation. IPCNet architecture also utilized deep interpoint controversial layers to exploit the local correlation among neighboring points, so thereby it improves segmentation accuracy. And there is graph correlation network, I'm sorry about my pronunciations, which have provided a very powerful framework for encoding spatial relationship with point cloud, enhancing the segmentation process. So all these recent advancements in this field was mainly driven by computer scientists, engineers, and a few computational designers. So as the field undergoes rapid growth, much of the attention has been directed toward resolving technical limitations and optimization, so frequently neglecting the practical application of this tool in the real-world context. So in architecture, the concept of space holds a significant primarily taught that it's interaction with the users. So the objective of this paper is to establish a connection between space and people to gain a deeper understanding of architecture. So this is where we refer to design anthropology, which becomes essential. So cultural studies in general, they analyze design within the broader social, political, and cultural context, exploring how design practices not only influence, but also are influenced by the societal forces. So design, as defined by social scientists, is to conceive an idea and plan it out, giving form, structure, function to that idea. It's also the process of design involved thoughts, planning, and it is frequently portrayed as a universal human ability that sets us apart from the natural world. So further, the design process requires the integration of field-specific knowledge with a large understanding of human being. So the human being for whom the design is made, the social circumstances in which the acts of design takes place, and the human context in which designed artifacts are used. So design anthropology in this context is an expanding interdisciplinary field of literature on design and anthropology, and it investigates the relationship between people, objects, and the dynamics of production and use. So the shift in design towards a user-centered perspective and its implication for our understanding of objects and products, along with their creation and use, have been the focus of two important publications. So the first one is Clark's edited volume, Design Anthropology, Object Culture in the 21st Century. And the second one is Gunn Donovan's edited volume, Design and Anthropology. So the following arguments and references will be derived from these two books. So in order to understand design anthropology, we need to acknowledge that it bridges two distinct methodologies. So design and anthropology are two different disciplines. And here we have a new emerging discipline that's called design anthropology. So where does it really fit? So first of all, design anthropology aims to develop tools and practices to actively engage individuals in shaping the future and practices for creating futures together. So differently than design that is very future oriented, and anthropology, which is very much related to the social changes and their observations, design anthropology aim to create some tools to bridge these two different perspectives. Second, design anthropology aims to create methods that use various forms of intervention to generate contextual knowledge and devise specific solutions. So in design, we have this program or function-oriented, let's say, expectations or problem definitions. in anthropology, we have this participant observation. However, in design anthropology, we seek to develop these new tools that can bridge the two. And finally, design anthropology practitioners work in multidisciplinary teams, taking on complex roles as researchers, facilitators, and co-designers in design and innovation process. Because designers or architects, let's say, are very used to work in collaborative processes. We have many stakeholders, we work with engineers and so on. However, in anthropology, we cannot see that kind of practices. So design anthropology introduced that kind of methodology to the field. So what's the potential for merging segmentation's quantitative data with anthropology's qualitative contexts? So design anthropology, as I said, seeks to create an impact on the field of design by transforming it into a practice that is more inclusive, humane, cognizant of the historical context. So essentially, it works toward a decolonized approach. So this transformation is achieved by integrating 3 specific anthropological characteristics that would enrich the design process. 1 second. So the first of these techniques or strategies, let's say, is the role of theory and cultural interpretation. Design anthropology draws from a rich tradition that prioritizes contextualization and the interpretation, weaving these elements into the fabric of the design tasks. So this approach emphasizes the generative potential of the theoretical framework and encourages a critical examination of the existing conceptual paradigms that often operate in the background, largely unexamined. So for instance, here, curtains might not be the essential component of a facade segmentation. However, in some contexts, it is, and it should be. So the second one is systematically investigating the past to understand the present. So there is a fundamental tension in design, which often focuses on the creation, innovation, and the concept of future making. However, anthropology takes a systematic approach to investigate the past. So the historical inquiry is essential for understanding the present and informing methods of anticipating, foreshaping future outcomes, highlighting the importance of historical context in the design process. So we know that semantic segmentation is highly used for historical building, and it is really it has very advanced techniques. However, we must acknowledge that time is not only related to the past. So temporality of the space, its transformation within short periods of time is also essential and should be understood and investigated. And finally, the diverse value systems and priorities of various groups. So ethnographic methods, of course, is, if most of you know, provide a very keen sensitivity to the diverse value system and priorities of various groups impacted by design initiatives. So this includes a focus on marginalized communities, consumers, producers, or broader audiences. So ensuring that the design process not only serves a select, but is attuned to the need and aspiration of all stakeholders that are involved. So, for instance, here you have an example of segmentation. However, the sink in Afurada's laundry room have a completely different meaning than a sink that is in a bathroom. So 3D point segmentation is creating a paradigm shift, which is the ability to extract and categorize detailed information from raw data. This allows for more informed decision-making, improved automation, and enhanced interaction with digital and physical environments. The question is, can these applications be adapted to contextualize and interpret user interaction, investigate the past to understand the present, and value orientations of various groups to design cultures of the future and for fostering connection, repair, sustainability among the built environment and its community as acknowledged by design anthropology. So there are a lot of advancements in heritage studies, in architectural heritage, when you look into semantic segmentation. So here is an example of Masher et al., which present a semi-automatic approach that reconstructs the interior of the building and identify the critical structure elements. Or you can see the second example, which demonstrates how deep learning frameworks can extract specific features from point cloud of ancient building, allowing for a detailed examination of structural changes and degradation. However, when we get to understand agents, let's say people in the space, we can no longer target them in 3D point representation, but we transform into other mediums such as images or videos. So here you see some examples of semantic segmentation used in images or from videos, and even there are some explorations in the VR environment. However, it's possible to see very promising examples in art industry that use 3D points cloud modeling to illustrate very active components through the urban fabric. So this is one example which illustrates a very vibrant flow of the circulation of vehicles, people through the city within a growing setup. Here, this is an example from a Turkish artist, Erdal İnci, which illustrates the interior of an existing street and building with very much details. It's very accurate and it holds a lot of cultural information about the space, about the use, and so on. And here is another example by Mind Workshops. And it captures not only the landscape, this is the Central Park in New York, but it also illustrates all those immersive activities in that specific spot that they selected to represent. So to conclude, by combining point cloud segmentation with design anthropology, we can adopt a human-centered approach that considers cultural, socio-economical context. So this method can improve our understanding of the connection between use, space, and architecture. However, we should keep in mind that the integration also raises very important ethical considerations, such as privacy, surveillance, data ownership bias, and environmental impacts. So thank you very much for listening.
I had to move my car before I get a ticket. So I'm back. So the next presentation will be integrating additive manufacturing with BIM. by Jaime Cunha, a case study in sustainable architecture and construction. I guess Jaime is already there. Hello. I am very pleased for Jaime to be here. Jaime is a former student of mine, and I'm really glad for your track and really curious to know what you're doing. Whenever you want.
In Porto, then I moved to London, where I work in a virtual practice, doing different type of project, architectural. And 2 years ago, I decided to come back to the academia and study sustainability applied for the built environment. This is part of my dissertation, which I just finished in September. And I also started the PhD with the same topic. Also work with the same companies. So this is a case study with the company Avlar, which is the first construction company who built the first 3D printed house in Portugal. The house is here, located in North Porto. So the way we structure the presentation, I will brief a bit about additive manufacturing and the potential to reduce the environmental impact. I will present the case study itself, and with BIM, we were able to propose some design strategies to optimize the design and also the efficiency of the house itself during the life cycle. So we all know the construction industry is saturated. We have a shortage of workers, and we need materials with less pollution, which deny the raw materials. And also, we all know we need to achieve the net zero for 2050 on the construction industry. In this sense, additive manufacturing is one of the processes to tackle the carbon footprint on the construction industry. So briefly, is required to study the construction system. It started less than a century ago in 1939. We were able to print a house in a circular shape supported by a pole, and that was some constraints. In 1997, we were able to print with the technique of contour crafting supported by the crane. And recently, we are able to print with a robotic arm. This example is from the company Icon, based in the US. And the printer is called Phoenix, which prints still 8 meters height, which gives us, allow us a lot of flexibility. Also was required to understand when we start to study this example, and with what kind of materials, from the concrete, the clay, the plastic, or artificial stone. So we can see till 2012, there was like a slow pace, and recently we start to study across the country, which you don't see the map here, across the world, where we use or have been studied. Was also required to understand the materials and the location of these buildings as organized by a timeline in the different countries. So we understand exactly what we have been doing recently and what was the aims or the challenges over the last decade. One of the big points of this research was how we should print or how we should proceed with this construction type. If we should move the printer every time you have a new project, or if you should start to print offsite in an industry where you control the environment and you just move the printed walls to the different sites. And with this thinking, I decided to highlight 3 different projects. All of them are off-sited. And of course, we can understand the flexibility of the design, the improvement, which you can see. We will always see the joints, as you can see, but there is a lot of flexibility what you can have. And of course, we also can use as a air-based fortification
That example it's the most recent one. Regarding the materiality, those three houses are have in common the materiality, as I said, are with the material is with the straw, wood, cork, and cobalt. They also have sustainable features. For example, the last one in Lombard, they have the cross ventilation with the skylights. But it is also important to highlight with the local materials, we can have a sustainable construction to enhance the construction industry. During all of this research, we found this company in USA, which is called Mighty Building. They can complete the whole process since producing the panels to transporting and assembling the house itself. They also have created this material, which they call Lumus. It's 5 times more tensile and flexible than the concrete and weighs 30% less. Of course, it is based with plastic, recycled plastic, but it's also an improvement for the construction and for the future of our planet. So after all of these case studies, it's required to evaluate or to study a tool to evaluate how the pollution is going. So a LCA system has to was indicated for this process, where we study the material since we have the resources, the process to manufacture, distribute, and use, and of course the end of life process of the material itself. So with this, you can evaluate to reduce the environmental impact of the materials or even the process, and studying the process itself. And in this case, we did from the cradle to grave of the house. Starting to explaining the house, that's 80 square meters. It's located here in Porto, and it's a 2-bedroom flat or house in itself. It was printed by the Cobalt, the model BOD 2, and that was printed in 18 hours during 3 days. So that was very effective to print the walls. And the LCA, which I'm going to show after, was proposed for 50 years time. So now contexting with Avelar, as I said before, they built the house, and right after, at the same time they were building, they contacted the university. That's when we team up together. And because the house was already built, I started to analyze first the CO2 emitted by this prototype. And then I was proposing some changes, which I will show later. As you can see in the plan, this is like the built elements are basically almost the same, the walls. So there is kind of a neat design itself. In terms of the planning of the study, as I showed before, there's a prototype. We collected the data from the materials, the distance, energy consumption, and the waste produced, the EPDs from the materials, the goals defined with the company in terms of sustainability, the financial, and the performance, the experimental plan, and we evaluate the LCA, and we create the design strategies. The life cycle cost was not possible to reach because they didn't have any costs, any financial part. The materials are more or less gave from the different companies. So the case study the model was produced in Revit, as I said, and the analysis was produced in one-click LCA, a plugin within the Revit. So in the beginning, I feed the model with all the data extracted, and we reached the C category. Why this is so high? As you can see, the LCA, we did the cladding. We studied the cladding of the building. We didn't go inside, but we were able to study element by element, from the skylight to the sandwich panel as the roof. But the most problematic is the mortar we use for the printed walls, and the structure, because this house requires a structure to be built in Portugal. In Portugal, this kind of type of construction cannot work as a load-bearing walls. The legislation obliges to have a structure. And in this case, that was a I-beams. So it consumes 20% of the pollution of the house. After this, and making the context to the global construction, we decided to do a comparison with the same house, comparing with if we use a formwork for concrete walls for the same shape, which automatically we assumed that's even worse, which goes to the D category. And the reinforced concrete walls will go for 52%, which is 27 tons of CO2 emitted, which of course proves what everyone thought. Right after, and because we have been studying the offsite proposal, it's just moving or just splitting the same area of windows and make them both or dividing. So at least we can have small panels. We can reduce the trucks to move the panels to the site. Or even if you go further, and if you use a lighter mortar, which weight less, for example, with a mortar used in USA in the Mighty Building Company, I just showed, we can reduce the CO2 emitted with the transportation of these printed walls from the factory to the site. So this was another study to optimize, which automatically gave us a classification of A. But therefore, the printed walls were still a problem, one of the biggest polluted in this case study. And we carry on with the studies and the proposals. And bringing the laboratory where I'm studying right now in Philp, which is the DG lab, digital construction in Philp. With the company, we are studying a mortar based on earth, soil, to be able to print these elements. And I was not the main character in this study, but I was supporting the team during the printing process and analyzing the elements on lab. Also, on the prototype, we are testing the air quality in terms of temperature and internal pollution or air quality. And within 1 year time, next March, we will understand how the temperature is different or not. And in this example, the number 4, we could have a classification of A. So now I have to say the printed walls, okay, you can see here, the printed walls are, I assumed we can use the same mortar in soil, but to have some rigidity, the structure is a CLT structure. So the columns and the beams and the roof itself, we swap from the metal to a wood structure and automatically gave us good rates in terms of classification. At the last one, if we consider carbon sequestration over the life cycle of the house, I mean the 50 years, we can understand the building can reduce the pollution itself. I know there is many ideas regarding how the green roofs are sustainable or not, but at least during the life cycle, I know we know it can reduce significantly. So as you can see, right after the construction, of course, it's more polluted because we require different layers on the roof for the membranes, for the green roofs, but with time, it reduced significantly after the 50 years, which It should move. It should move.
Uma imagem muito grande, vídeo.
Okay, perfect. Sorry, and then there is a synthesis of the process and the project. So we understand the first design, which is the case study, and then supported by the Revit, we changed the dimensions. We took the bill of quantities, and we were applying the different materials with the different EPDs. And of course, we get from the 47 to the 51, 25th, and the most accurate, which is the soil walls with a CLT structure. And the same example, if we use a green roof with a life cycle, it will have a better performance of on the design. And this is just a summary for us to understand where the prototype can work, from the prototype to the traditional construction, and do with the sustainable materials. So thank you.
Thank you. Well, next presentation is about nature's integration in architectural ornament through photogrammetry.
No,
Pedro.
I'm Pedro.
Varela will present. Francisco is not here.
Francisco is in Japan.
Oh.
All right. Okay. So thank you for staying here until now. We'll.
We have dinner then, don't worry.
Yes, yes. That's the only reason why. So I'm not Francisco. Francisco is in Japan. He was a student of mine. We developed this work together. This was his master thesis. I wanted him to be here presenting, but unfortunately for us, but fortunately for him, he got a scholarship. He's pursuing his dream. He's in the Tokyo University of Arts, and I have the honor of presenting our work. So for our introduction, we have seen that in many times, many cycles across the history of architecture, and here we present one of the most studied and symbolic ones. There is cyclically a tendency to complexification and ornamentation of architecture. And we see this from the Doric order to Ionic and Corinthian. It gets ever so complicated. We see this from Roman to Gothic and Flemish Gothic. We see this again from Renaissance until Baroque. This goes over and over again. And we should also note that when it becomes very ornamented, these natural themes usually arise, okay? And we also see that today with many works of architecture. These are just two, of course. Not all of them, of course, there are many styles, but we see currently with the digital tools that we have at our disposal, we see many manifestations of natural themes of organization of form and shape embodied in architecture. And not only in the fine decoration of elements, but also in the structure, for example, assuming some sort of biomimicry. So, as we see, nature has always influenced architecture design, as we know, even Art Nouveau, all of this. And today it is easy to generate these shapes using the computer. So the hypothesis is, why don't we digitize nature into the computer? This is the hypothesis of the work. And this is one image that somehow, it's not a synthesis, but resumes a little bit of what we are doing here. We are using digitization, in this case, photogrammetry of natural elements through a series of photographs, and we achieve a 3D model with which we are going to produce architecture elements later. So the objective is to understand if this technique, photogrammetry, which is the technique that allows us to get dimensions and ultimately a 3D point cloud from various photographs, if it can be used to incorporate these shapes into our designs. So just for a little bit of context, photogrammetry as a technique has been incorporated into architecture in the first moments as a tool for heritage conservation, not only for the archival of elements using a digital twin, but also for producing repair work, because you have it's like a super survey. So you get a very detailed survey of the element you are working on, so then you can use it to make missing parts, for example. On the other hand, not photogrammetry, but other types of 3D scanning. Frank Gehry's office, 3D scanning of reality has also been used to generate architecture. In this case, not nature, but well, crumpled pieces of paper, as in the Simpsons episode. On the other hand, more recently, for example, in 2021, this artist, Yuko Oda, used this technique of scanning natural objects to create a sculpture, for example. And this gives us the motivation to use this technique to further explore architecture creation. So for this, we are using 3 different categories of experiments. And these are volume, which has to do with the, well, volumetric 3D exploration of shape, relief, which has to do with some kind of like alt relief, bas relief or haut relief on the plane itself, and then on just a 2D surface. So on the volume, we have 2 experiments. The first one is to get an architecture, a natural object, and understand how it can be understood in a completely different scale. So we use this project as a reference. So this is the Las Setas. So this is the Metro Sol Parasol in Sevilla, by Jürgen Mayer. And using this idea of a waffle structure, we acquired a point cloud of a set of mushrooms, real mushrooms, because here we have, this is an interpretation of mushrooms. So it's a natural, well, I don't know if the origin is mushrooms, but in Spain they call this the mushrooms, las setas. But in this case, we were using real mushrooms. And after getting this point cloud, we generated a mesh, and from this mesh, a waffle structure, which is more than known. With the waffle structure, we got the plans which were laser cut, and we got this model. So a real mushrooms setas pavilion on a model scale. So instead of having this, how can I say, interpretation of nature, we have a very mimetic production of nature itself. On the other hand, another example that was studied, it's Toyoito's Sendai Mediatek, where we have this building where the structure is made by these columns of made of steel elements, which, well, each column itself is made of little columns, maybe we can say. And so the inspiration was a pine tree. So once again, lots of photos of the same pine tree. We create the photogrammetry. Well, the software was a mesh room. Maybe you know it. And from this 3D model, where we can see here a depiction of the 3D model, there was a routine in Grasshopper to understand where we could have these cavities. Okay, so I think there's a pointer thing here. Where's the pointer? I like the pointer. Here. So here we have the cavities of the tree. Okay, so with the routine in Grasshopper, from these points in the inner circle, we discovered where was the closest point of the mesh to these points. From this point, we see what is the closest point of the mesh to this point. It is this one. So we get this point, and then we connect these points on a vertical fashion, and we get these canals, these vertical elements, which is an interpretation of the tree itself. So, and from here, we try to describe these elements here. And in this case, there was a 3D printing of the structure. And the final result is this. So once again, a very direct relation between the natural element and the architecture element. And here we can see how this could be embedded on a similar architecture work. I think it's quite understandable how the left one looks more natural, more related to nature than the one on the right, which does not mean that it's wrong, the one on the right, of course. Then another experiment uses textures. Okay, so this is leaves on a wall, hera, how do we call this in English? Ivy leaves. I think it's ivy leaves. So once again, a point cloud. We see there an elevation of the point cloud, a plan of the point cloud, and this is a depth map. So it's a Z map. So the white is the one closest to us, and the black is the one farther from us. And this was post-processed and made as a texture. Okay, and from this texture, it was applied to a plane and a cylinder in order to create volume. And we have this. This is the volume. The problem here is that we were getting this. So although this is the real geometry, because there's a leaf here, with a bump map, which is or just a vertical displacement map, what we got was that. So instead of having this concave part, it just went down. So it was not truthful. As we can see on this image, it shows better. So then we made a different strategy, also to have better elements. And this is one of the interesting characteristics of the work, is that instead of modeling something different, you go and fetch a different element from nature that maybe is more useful to you. So then we got these leaves, which are more thick, and also we arrange them on the floor so that we get the composition that we want. And something that we also discovered is that for an somehow automatic way of reducing this cantilever is to, on the act of the photogrammetry, if you use a smaller capture angle, you will not get so much information beneath the leaves, so it will automatically have a smaller cantilever, as we can see here on the right. So the greens are less pronounced than the reds. So here we used that model repeated in an array fashion, and we didn't create the bump map. We used the model itself, the mesh itself, and you get this very intricate, detailed surface on the column, as you can see on these 3D printed samples. But we are presented with a dilemma. The depth map gives you good repetition, but bad detailing. And if you use 3D models, you get good detailing, but it's bad for the repetition, because it's also better to have maps that you can reproduce and apply to any shape. So how can we get the two together? So we had the idea of using vector displacement maps. So a vector displacement map is, instead of a bump map where you just have the part that is closer to you and in white and the further from you in black, it's a map that uses color, and it uses the RGB system to produce polar vectors. And so it says where some pixel should go. Instead of just going up or down, it can go in any direction. So with one image, which was ultimately this one, it's not super understandable, but you can see that, for example, the ones to this side are red, the ones to that side are green, and the ones coming to us are blue. We were able to repeat the same exercise and achieve a very good result with just the repetition of one image. But this was a big challenge to use this kind of system, because it's better to use this system when we are actually using displacement maps on modeling and not for already made models from other strategies. Finally, digital composition. So now we used this different inspiration. It's the Gantenbein. It's like a Gantenbein winery by Gramazio and Cola. And this building has these bricks that are rotated slightly. They were assembled by robots, but our interest here is the actual pattern on the surface. I don't know if you notice, it's like spheres, and these spheres were produced by them by making a digital simulation of spheres falling into a box, which stand for the grapes on a box. Okay, that's for the winery. In this case, we went for pine cones. So there are lots of pine trees here in Portugal, and we made a similar simulation in the computer. Okay, in Blender. And from this image, we gathered a 3D rendering with light so that we can see better the shape of it. And from this image, we got a half dot pattern, that one on the right. And using this half dot pattern, we didn't produce, but we made a simulation of how this could be applied to a facade, to panels on a facade, where you have these patterns inspired by nature. So this is like a synthesis table of all the experiments that were made. And so as well, in conclusions, photogrammetry, we see that can really offer a way of incorporating the complexity of nature into architectural elements. The digital texture is a very good tool to give this relief to an already made, already modeled architectural element. For example, when we are designing in BIM, we have a wall, we have a column, just flat surfaces, but then we might want them to come alive. So then the digital textures are a good way to do this. And photogrammetry is very good for this kind of strategy in architecture. Challenges. Although photogrammetry is affordable because you can do it with any camera, even on a phone, it works better when you have well, better cameras or tripods or something to generate better results. As I've told, the vector displacement map, it's not as a technology to create a vector displacement map from an existing 3D model. It's not so easy. It's actually quite a new strategy in the field, and there is not still it's not very seen today, this kind of information. Future research, understanding how other 3D scanning tools like lasers or LiDARs can be included in this, how color can be also included in these kind of strategies. As you've seen, we've made everything in black and white, can I say? And other digital manufacturing methods can make these models come more alive and closer to reality. And well, thank you. And there's arigato written in Japanese. Okay, cool.
Thank you. Call the other presenters to the table, please. Amina. You can join us, please. Yes. Sit. So, questions, comments, remarks? Yes, Sabi? You have, yeah.
Because I don't have a question.
Meta, go ahead.
I'm not an expert in these fields, so I'm not going to ask a smart question, but I thought it was very fascinating, and I saw so much potential if you two start working together. Yeah. Or maybe actually all three of you, because maybe we need also, let's say, some perspective on what we want.
I forgot to say something very important. We were already colleagues 5 years ago in the DFL, in the Digital Fabrication Laboratory here in Porto. So it was really cool that just out of luck, we were on the same session.
And at least Amina was already in the previous edition of Formal Methods. So yeah. Yes, Abi.
Great. Yeah, thank you for your presentations. Really nice, to end the day on. Just a question to the last speaker. Because when I was looking at the biomimetic approach, obviously you are deriving the exact forms. However, you did not mention at all the structural logic or the, yeah. So what's the attitude towards that? Is it just the forms, or do you need to understand the logic of the feature in nature that you are copying?
Of course, that we know that nature has a very wide array of lessons to teach us. Okay, on this case, the work was purely geared towards form. So just grabbing the form of nature and putting it in architecture, not only on a super mimetic way, like in a hyper realistic sculpture, but interpreted according to different approaches of architecture, but it was purely form.
More questions? I have a comment. When I started lecturing in 2000, I started lecturing drawing first year and second year. And I used to join with another professor, is an anthropology professor. And we used to go to the Ilhas do Porto, the islands here in Porto, where it's a urban structure where usually poor people used to live. And we go there with the anthropology professor for him to talk about space appropriation, and for my students to sketch the space appropriation of the ilhas. So I used to do this with a pen, a pencil, a sheet. The next time I will do this, I will use photogrammetry. It's amazing. I really found it amazing. So the possibilities to increase how to get the way the appropriation of space is combined and work, it's really good. So this is something that I remember when I used to teach drawing in the school with that professor. Putting this apart, any other question?
Only some questions to Jaime. How much is the percentage of Portuguese research in the project? Because I think, for example, the 3D printing is not Portuguese equipment. I think. The first question. Second is how I think it's concrete. The walls are in concrete. Well, only concrete is not very good, although it's a very good for thermal mass, but not in isolation. How you solve it?
So thanks for the questions. So this is a Portuguese company, Avlar. They just started 2 years ago. They are part from Icons and they are based here in Maya. Yes, the equipment is from Denmark, but all the resources are based here. Our local resource, at least they are trying to. For example, the earth or the soil mortar, I shown as in the third example, is elements or their aggregates within 100 kilometers away. So they are trying to reach sustainable with all the parameters, all the aggregates they are using. Did I answer your question? Okay, the concrete thing. The house, when I reached the project, the case study was already built. The concrete is from it's a mortar from Weber. And they claim that it's Portuguese. They have the aggregates here. In terms of thermal performance, between layers, so each layer has 7 centimeters, and they are stayed away like 20 centimeters. And in the middle, they fill in with cork aggregates, like the last bits of the cork. So that's a circular on it, and that's an incredible for the thermal performance. That was one of the firsts on the top of the elements, one of the elements on the top, and the ones I didn't decide to study to improve even better, because that's already a good material, end of life, and to use the aggregates of cork, it's already very beneficial within the site location.
I'm sorry, can I add a little bit to this? Well, the DFL, the Digital Fabrication Laboratory of the Faculty of Architecture in Porto, is also related to this project. So I know something, so I just add a little bit to that. You get the machine, you know, but you put the machine here in Portugal and it doesn't work, you know. You need to put it to work. Okay, you turn on the button and then what do you put inside the machine? So you have to study the composition of the concrete, which is for different concretes, it's different in different places. And then here, humidity, temperature is different. You have to, I mean, there are options, many options, as well as the José Pinto Art would say. I mean, the layer height, the speed, how much time can pass between the moment you create the concrete and you start injecting it. How do you insert the rebar or structure? So all of that is Portuguese knowledge, research, people are doing it. So do you understand? I mean, I buy a machine, but then the machine doesn't work by itself. You need to work with it.
Well, just complete the way I embrace this project. Coming back from London, where we had like prefabrication and buildings in days, was very amazing to arrive here and see a company. They just bought the machine and they believe in this project, and it's something for the future as a construction industry, which will enhance and will perform better to us.
Are they incorporating the sort of monitoring process that you are implementing in the buildings, in the building process also?
Yes, that's part from our laboratory in Phil. Speaking about digital twin, they are also tackling. It's not directly my group, but it's another lab within the same lab. They are working on the IoT and monitoring the construction.
With sensors and stuff.
Totally.
Any other question? Everyone wants to dinner. Well, I still have one thing to say. I don't know if we have time. I guess we don't have time or patience to do it because we have a book presentation after this. We are so tired. I won't give you that. We'll skip. This is a Portuguese organization, so we can skip wherever. So we skip the book presentation. Nevertheless, give me my back, please. Just, yeah. Nevertheless, just for you to, because Rudy's is here, so I need to remind you that because this is not ending here, after the symposium, you already start to work on the papers, on your articles. So I really appreciate that you, after the symposium, keep working with us because we are going to publish the papers of this symposium again in this collection by Springer, that Rudy's is one of the editor. We have already set the publication with them. We are just now preparing the book with the articles and the contents, etc. So we will be bothering you after the symposium for you to give us your paper. We will probably ask you to change whatever. You will probably want to change something in your papers with the contributes of the discussion that the symposium brought to your presentation. So you are free to do it. Oh, Franklin is even worse than I am. I only brought one for you to take short time, and Franklin brought the other three. This was the first one. I don't know, 2018. Okay. So this was the second one. 20. No, 20 is this one. Sorry. Yeah, 16. Yeah. This is the first with Springer. This was the one from Ischte, yes. The symposium we did in Ischte. The first one with Springer. and that one is from the previous edition. And we will have the proceedings published with Springer in release collection. So please stay with us after the symposium, because we will need your contributions, your papers to the book. I don't know when it will be published. It's just something that we will have to deal with. But next year, let's say 25, somewhere in 25. 6 months. Okay, he's an optimist guy. 6 months. So this is the request I would like to highlight for you to stay with us after the symposium, because we want to publish again with Springer the proceedings of this symposium, and we need you to do that. That's just it. And thank you for today. Now we have dinner. I will shut up. We are all tired. We need to eat and talk about everything else. Then and now be informal, be quite informal for the next 4 hours. I want you to be absolutely informal, okay? And enjoy dinner and follow us for dinner. I don't know where the dinner is, but I will follow him. So follow Katarina.